Welcome all to this new session on Finite Automata with Output. Myself Dr. Sunita A.V. from KL University. So today we are going to see Finite Automata with Output. Okay, the aim of the session on Finite Automata with Output is to introduce the theory and applications of automata that process inputs and generate corresponding outputs. And these are the instructional objectives and the learning outcomes. Okay, so when we talk about the finite automata with output, a finite automaton with output is a computational model that consists of a finite set of states, a finite set of input symbols, a transition function, an output function, and an initial state. So the additional thing here is output function when we compare it with the finite automaton. This type of automaton is used to model systems that produce outputs based on the input symbols and the current state. Finite automaton can be divided into two. One is the Mealy machine and the other one is the Moore machine. And what is these two? Okay, in Moore machine the output is attached with the states, and for the Mealy machine the output is attached with the transitions. Okay, so whenever the machine enters a state, it generates output in the case of Moore machine, and in the case of Mealy machine, the machine generates output whenever it takes a transition. Okay, so the general definition is like this: Q, sigma, delta, Q0, capital delta, and lambda. So Q, sigma, delta, and Q0, all these are same as that of finite automata. That is, Q is the set of states, sigma is the input alphabet, delta is the transition function, Q0 is the initial state. And what is these two items? That is the capital delta and lambda. Capital delta is the symbols that we use in output. Okay, so what are the symbols we are going to generate in the output? That is specified in delta. Then lambda is the output function. Okay, lambda is the output function. So Mealy and Moore machine are going to differ only in this output function. So in the Mealy machine, the output function is this, that is, it takes two arguments. One is the current state and the current symbol, input symbol, and it will generate the corresponding output value. Okay, so in Mealy machine the output is along with the transition, and in Moore machine one output is attached to one state, and the only input the function takes is the current state. What is the current state? So for that current state one output will be generated. Okay, let us see an example for Moore machine and a Mealy machine. So in this first one there are four states, Q0, Q1, Q2 and Q3, and along with these states we can see some values 1, 0, like that. So in Q0 there is 1, Q0/1, that means the output of Q0 is 1. Whenever the machine enters this state, 1 will be generated. And in Q1, Q1/0, so 0 is the output with this state. Whenever the machine enters Q1, the output 0 will be generated, and in Q3 the output is 1. Whenever machine enters Q3, the machine will generate 1. Then in Q2 the output is 0, and the transitions are same as that of the other one. So in Moore machine the thing is, whenever the machine starts, one output will be generated, because in initial state itself we have some output value, so without consuming any input it will generate some output. That is the case with Moore machine. Then when we go to Mealy machine, the second example, over every transition we can see two symbols, A/0, B/1, A/1, like that. So in this the first symbol is the input symbol, A is the input, slash we give another value, that is the output value. So here the inputs are A and B and outputs are 0 and 1 in this machine. So from transition from Q0 to Q1, the transition says that when the input is A, the machine will take a transition to Q1, and at the same time it will generate the output 0. And similarly from Q1 to Q2, Q3, there is A/1. So when the machine takes this transition, it will generate the output 1. Okay, like that on every transition we have an output value. Whenever the machine takes that particular transition, that will be that output will be generated. So okay, so in the case of Mealy machine, if the input string contains n characters, n symbols, the output will also contain n characters, n output values. That means whenever we consume one symbol, one output will be generated. But in the case of Moore machine, if the input is n, string n, string with length n, then the output will contain n plus 1 symbols. That is because in the initial state itself we have some output value. So in initial state we are not consuming any input value. So without consuming any input value itself, it generates one output symbol. So Moore machine will generate one extra symbol. Okay, so if the length is n, input length is n, the Moore machine will generate the output with n plus 1. The one extra comes from the input state. Okay, then another thing is this Moore and Mealy machine are interchangeable, or if Moore machine is given, we can convert it into Mealy, and if the Mealy can be converted into Moore machine. That is the thing. So how we can convert Mealy machine to Moore machine and Moore machine to Mealy machine. So it contains 3 steps. First step, find out a different output generated with the Qi in the next state column of Mealy machine. So we consider the transition table and do this. Then split Qi into different states depending upon the output generated with it. For example, if output generated by Qi is 1, in the first next state column and 0 in the second next state column, then we have to split Q1 into 2. Q1 0 and Q1 1, like that. Now copy all the present states and next states in the Moore machine format, and output of the next state are common. Okay, so this is the 3 steps for converting Mealy machine to Moore machine. So let us take an example. So this is the example sample machine, Mealy machine. So every transition we have some output values. Okay, so this is the next state and this is the output values, like this. So for this Q1 there is an output value 1. Okay, then we search for another Q1 state. So here another Q1 state is there, the output is 1. So for Q1 state, it generates, in all the transitions, it generates only one output. So we need not split Q1. Then you consider Q2. Here we have Q2 and the output is 0. And you check for another Q2 is here, output is 1. So the same Q2, we have 2 different output values. So what we have to do, we have to split Q2 into 2 states, Q2 0 and Q2 1. Similarly, you check for Q3. Q3 is also Q3 1 and Q3 0, both are there. So you have to split the state Q3 into Q3 1 and Q3 0. Okay, one will generate the output 1, the other one will generate output 0. Then for Q4 is generating only 1. For attached with the Q4, only one output value 1 is there. So need not split Q4. So Q1 and Q4 they are generating only one output, so we need not split them. But in the case of Q2 and Q3, they are generating 2 different outputs, so we have to split it into 2. So the output will be like this. Okay, so Q2 0 and Q2 1 will be new states will be there, Q3 0 and Q3 1 will be there. Then the transitions we have to draw accordingly. That is the Mealy to Moore machine. Then the reverse conversion, Moore to Mealy machine. So the states, every state has some output value. We have to transfer it to the transition function. So draw the Mealy machine table, copy all the present state and next state column of the states into the table. Then for output column of the next state, check the present state and its output generated in the Moore machine table, and that value will be copied. So for example, this one Q0 has output 0, Q1 has output 1. Then what we have to do, all the Q0, all the transitions coming in to the Q0, we have to transfer this 0 to those transitions. So we have a self loop over here, so transfer this 0 to that transition, and there is another transition from Q1 to Q0. For that also we have to transfer this 0, output 0 to those transitions, And in the case of Q1, there are two transitions coming in from Q0 and the self loop. So the output value 1 will be transferred to those two transitions, 1 1, like that. So that is easy to generate like this. So from Q0 the 0 will be transferred, and for this also 0 will be transferred, and for Q1 1 1 will be given. So that is how we do the conversion from Mealy machine to Moore machine, and Moore machine to Mealy machine. And then these are the some Moore machine is an application of what? These are the quizzes, self-assessment questions you can go through. Okay, so that is all about the Mealy machine and Moore machine. Okay, they are generating outputs. Okay, so the difference with the Mealy and Moore is Mealy machine is the transition output is attached with the transition, and for the Moore machine the output is attached with the states, and the interchanging is possible because they are equivalent. Okay, so that is all about this session, output with the finite automaton. Thank you all.